Hello students, to fully understand the concept of fault distance to fault estimation by traveling wave method, you need to understood first the transients in AC power system. Okay, to understand the meaning of transients in AC power system, I have developed transmission line model with some load, fault and source bus etc. in MATLAB. How to use that model and how to understood the meaning of AC transients I will show here. This is the model of transmission line supplying some load which I have shared with you. This is the transmission line pi section model. Details about this I will share with you afterward, but for now just consider it is a three-phase line and its length is 50 kilometer. Okay, and this is our source. Source is of 25 kV phase to phase voltage, that is line voltage. Line voltage is 50 kV and 60 hertz. Okay, and now this is the breaker through which we are charging the line. So this is our source, this is our breaker through which we are charging this line, and to this line at receiving end we have connected, this is a load which we have connected to this line at receiving end, and this breaker is controlling the load. That means we are making the load on or off using this breaker. And this is the fault which may happen on the line at receiving end. All this data we have measured using this block. This is three-phase VI measurement block. From here this data comes here, VIABC, VABC, and it get displayed onto this scope. Okay, from here how this data is getting displayed here, just I will explain you in short. Double click here. Here I have clicked this, what voltage it is measuring, phase to ground voltage, and here I have clicked this use ABC label. Similarly it is measuring the current, and I have here clicked the use label. So what are the label? VABC and IABC. Okay, and that label I have connected here by using the from block. It is called as demux. That is whatever the multiplexed signal, that is there are three signal in this line, IA, IB and IC. It gets separated into, this is IA, this is IB and this is IC. Similarly voltage signals, it is get separated into VA, VB and VC. All these six signals I have recorded on this scope. Okay, this is the scope, and these are the places for recording the signal. Here IA will get recorded, here IB will get recorded, here IC will get recorded, here VAN will get recorded, here VBN and here VCN after simulation. And what we are simulating now I will explain you. We are simulating the charging of the line. First we will charge the line, open circuit line. We will not charge the load. How? By making this circuit breaker on. What is the initial condition of the circuit breaker? Initial condition of the circuit breaker is off, and we are making this circuit breaker on at 6/60 second, that is after 0.1 second. We are making this on, circuit breaker on, and keeping this circuit breaker on up to very large time, that is 5000 by 60. It is a very large time, nearly 1000 seconds. Okay, that means throughout the simulation we are not making it off again. Understood? Okay. Then we are making this circuit breaker on after after 0.1 second, and we are making this circuit breaker, that is load, on after 15 by 60 second, that is 0.25 second. That means first we will making this circuit breaker on, then we are making this circuit breaker on at 15 by 60 second, that is 0.25 second, and finally we are creating this fault. Which fault? Here I will show. We are creating this fault, that is phase A to phase ground, AN fault, at 19.23 by 60. That means after some cycles, after making this load on, and after that instance, and after the 2-3 cycles, we are creating this fault, and we are clearing this fault after 2-3 cycles, that is 22 point. Purposefully I have taken this non-integer to create the fault at non-zero instance of the voltage. Okay, I think you have understood the complete our plan, and now we will simulate it for 0.5 second, that is 2 times the when we have made the our load on. 0.25 second we have made the load on, and for 0.5 second we are simulating this. Just run here, it will get simulated. Okay, it is simulating, you can notice it here. Yes, our okay simulation took place properly, and now we will analyze it for. These are the graphs. Just click here, it will get fit into this provided space. Okay, so these are the currents. Initially some charging current, random charging current at 0.1 sorry, not 0.1, this is the 0.1 second. Yes, are you observing this as a 0.1 second here? This is the 0.1 second. At this we are making the line sending end breaker on, so there is some line charging current from here up to here. At this is the 0.25 second. At 2.5 second we have made load on, so this current is increased. Okay, and at this instance there is a fault. Due to fault, current again still increased, and that fault get cleared here automatically. Okay, it is a transient fault, so it may get clear automatically. During that period actually breaker should trip, but purposefully we have not tripped it. Okay, so this fault is now get cleared, and the normalcy of the load get established. Okay, so after understanding this sequence of happening, now we are in a position what is mean by transients and how to detect the distance to fault using these transients. Okay, so what are the transients? Obviously in voltage you will observe these transients. Okay, so all these are the transient, these are the transient voltages. Whatever you are seeing up and downs, irregulars, all these are the irregular, not actually irregular, it is due to incidence and reflected waves. Incidence and reflected wave along with the AC wave, you are getting some voltage superimposed on this basic AC wave. As the time lapses, that reflected and incident waves goes on diminishing, and you get the pure AC wave. Okay, so now you have got here pure AC wave. It is from charging of the line without load. you will again notice some transients when you charge the load. Okay, from here at 0.25 second we have charged the load. Okay, I will go to 0.25 second, where at 0.25 this is 0.5, so obviously this is 0.25, and here you will notice some transients. Okay, where is my okay, sorry, it is I could not capture it properly. Okay, now we will capture that 0.25 second. Okay, okay, we have captured that 0.25 second properly, and you may notice here this is the 0.25 second from here where we have charged the load. Before to charging the load, the sinusoidal waveform is almost smooth. At the instance of charging the load, again there are the transients. These are the transients in the wave. These are the transients in the wave. Okay. Similarly, when there is a fault, where you are noticing the fault, here, this is the fault instance. This is the occurrence of the fault. Before to occurrence of the fault, there is a voltage signals are smooth, and at the fault instance again there is a transients. Okay, so you have to analyze these transients and find out the distance to the fault. This is your project. Okay, I think you have understood that project properly. Okay, thank you.